Hey, pleasant good day, and we are here to do the in class series and sequence questions. We have some unfinished questions here, and so we have to tackle it, right? And this is the document that when we did series and sequences in class, so you could check one of the previous videos when we did this document. And in this document, we learned about sequences and we saw what sequences are, and then we learned about the common difference, and we learned about the arithmetic progression and the formula for it once you know the common difference. And we spoke about the common ratio for a geometric progression and the formula for that geometric progression. Yes? So, all of these things are things that we spoke about. And of course, we have questions here that we have to do. So let's see if we could do these questions, right? These are questions that we did in class, but some of them we didn't do. Some of them, these in red here, we just skipped them for you to do at home. And so now we're correcting them, yeah? So these are the unfinished questions. So the first one here is to determine the formula for the nth term for these sequences here. And hence, for each find the fifth term and the 20th term. So the fifth and the 20th. So let's look at this first one here, part B. We have negative 5 minus 3, negative 3 and negative 1. Now the first thing I'm going to ask myself is, what do I need to do to negative 5? Negative 5 is A, the first term. And what do I need to do to A in order to get negative 3? Well, I'll need to add 2. Yeah. And will that work? Negative 3 plus 2 gives me negative 1. Yes, it does work. So it looks like in this case, A is negative 5. And because this is a plus and not a multiply, means that this is an arithmetic progression. So for an arithmetic progression, and this shouldn't be A comma, this should be A equals, right? For arithmetic progression, we can see that the common difference here is plus 2. Therefore, AN is going to be A plus brackets N minus 1D. So this represents the general form. Now we put in our A and our D, so therefore A to the N, or A subscript N, is negative 5 plus N minus 1 times 2, which we could write like this: 2 into N minus 1, 2 multiplied by N minus 1, and that's a plus 2, all right? And then I have minus 5 after that. So, this is correct too, but this is just having good manners, yeah? Now we could find part 2, which is the fifth term, so therefore A5, right, will be 2 into 5 minus 1 minus 5, which is 2 into 4 minus 5. 4 2s are 8 minus 5, which is 3. And the 20th term is 2 into 20 minus 1 minus 5, which is 2 into 19 minus 5. 2 times 19 equals 38 minus 5, which will give us 33. We have part C here, which is negative 9, negative 6, negative 3. And I could see that this is A, and A plus 3 will give us negative 6, negative 6 plus 3, right? So therefore A is negative 9, and D is plus 3. A plus being a common difference, of course. So a to the n is a plus n minus 1 multiplied by d. So a to the n in this case will be negative 9 plus n minus 1 times 3, which I could rewrite as 3 into n minus 1 minus 9. A5 would be 3 into n, which is 5 minus 1 minus 9, which is 3 into 4 minus 9, which is 12 minus 9. Then we have A20, which is 3 into 20 minus 1 minus 9, which is 3 into 19 minus 9. 57 minus 9 is 48. We did part D in class, so let's talk about part E. I have negative 3, negative 6, negative 12. Very interesting. So we could easily see here that this is A. And in this case, A times 2. Negative 3 times 2 will give me negative 6. Negative 6 times 2 will give me negative 12. And so in this case, A will be negative 3. And the common ratio will be multiply by 2. What we're talking about here now is a geometric progression. So this is a GP because we are using multiply. Therefore, AN is going to be A times R to the n minus 1. We can see here that A is negative 3, R is 2, and we'll have n minus 1. Of course, we cannot multiply these two things if we have n. But we do have our particular form for this series here. So what we'll do is we will find the A of 5. Well, not the A of 5, but A5. Negative 3 into 2 to the power of 5 minus 1, which is negative 3 multiplied by 2 to the power of 4, which is negative 3 multiplied by 2 2s are 4, 2s are 8, 2s are 16. And 16 times negative 3 will give us negative 48. Now the A20 is going to be 3, negative 3 times 2 into 20 minus 1 to the power of. So negative 3 into 2 to the power of 19, which is negative 3 into 2 to the power of 19 gives us, whoa, because I got 524,288. I'll just multiply that by 3 one time to give us 1,572,864. And we have part F here, negative 9 times 3, negative 9, 3, and negative 1. If I multiply, multiply by negative a third, I guess, I will get 3, positive 3. Yes, because 9, negative 9 times negative a third and you'll get positive 3, and then positive 3 times negative a third will give me negative 1 indeed. So it looks like A is negative 9 and R will be negative a third, yes. So now a n is a r to the power of n minus 1. A n will be a negative 9 times negative a third to the power of n minus 1. So now we could find a5, which is negative 9 times negative a third to the power of 5 minus 1. Negative 9 times negative a third to the power of 4. 5 minus 1 is 4. And I will just do that in the calculator here. And the final answer is negative 1 on 9. Now then we had learned about these summation rules here, and pay specific attention to these three. You know, you have the when you multiply the sequence by a constant, the constant could come on the outside. Yeah. If you have just a constant, it will be the n times the constant. If you have two sequences, addition or subtraction, then it will just be the summation of the individual ones. And then you add or subtract that. And if you have the summation of a sequence plus a constant, it would just be the sequence of the summation of the sequence plus n key. We do have one unfinished question here, where we say that given the summation from I is equal to 1 to n of ai, where a is 3i plus 2. Right? So we're talking about, and the correct way to write it is the summation from I is equal to 1 to n of 3i plus 2, that is ai. So we have to find the 20th term and the summation from 1 to 3. Let's do b first, the 20th term, right? Because we know that part b, ai is equal to 3i plus 2. So therefore a20 will be 3 times 20 plus 2. A20 is 3 2s are 6, 62. But now we'll do the hard part, and that is part A, the summation of I from 1 to 3 of ai. That will be equal to, when I is 1 plus when I is 2 plus when I is 3. Not too hard. That is 3 plus 2 plus 3 2s are 6 plus 2 plus 9 plus 2, which is 24. So we have some summation questions, and let's start with number 1, part A. We have this series 2 plus 4 plus 6 plus 8 dot dot dot. But you can see in this case they actually give us the last term, and the last term, we can think about the last term as n, right? So we'll consider the normal series 2 4 6 8 dot dot dot. This is the sequence that it came from. Everything is positive, and we can see here that 2 plus 2 will give us 4, 4 plus 2 is 6, 6 plus 2 is 8. And so we have a series here Arithmetic series is equal to a plus n minus 1d, where a is 2 and d is also 2. And so the arithmetic series a is 2 plus n minus 1 d, and d is 2 as well. So an is 2 into n minus 1 plus 2. Now, when I say think of this as n, I don't mean put 100 in the place of n, No, I don't mean that at all. What I mean is this is the first term, the second term, the third term, the fourth term. So this is the nth term. 100 is the nth term, right? So we want to find out what n is. What is the last term? Is it the 20th term, right? So this is actually a to the n, and we want to find what n is. So if we know that this is an, right, the 100, that this would be the a of n that will give us 100, is 2 into n minus 1 plus 2. I could now find what n is when an is 100, right? So the reason why I want to do that, we'll see just now. But for the last term, I want to find what n is. So I'll throw across the 2. So 2 into n minus 1 is going to be equal to 100 minus 2. I'll throw across this 2 here. So n minus 1 is going to be equal to, that is 98 divided by 2, which is 49. So n is going to be 49 plus 1, which is 50. So this is the 50th term, which makes sense. Okay, so since we now know that the 100 is the 50th term, so n is actually 50. Yeah, and so when n is 50, an is 100, right? That is the nth term. So now we could come and see that it'll be the summation from n is 1 to 50 of this, which is 2 into n plus 1. Oh, sorry, 1n minus 1 plus 2. All right, so let's try number 1, part B, and this one is quite a bit tricky, right? We have 1 minus 3 plus 5 minus 7 plus ... and then minus 99 on the end. Yeah. If we just take a look at the series itself, the sequence itself, just taking a look at the sequence here. And these are the numbers that we're dealing with. And we have this very tricky situation of positive, negative, right? And if we check the n here is 1, n is 2, n is 3, n is 4, ... And well, this is our last value over here. Maybe we could call this n, right? The thing is, though, that if I was to try to find a common difference here, like 1 plus what will give me negative 3? Well, it'll have to be 1 plus negative 4 will give me negative 3. Right, so negative 4 would be the common difference here, but it does. If I add negative 4 here, it doesn't get me to 5. 5 minus 4 does not get me to negative 7. So no, a simple common difference does not work here. What about a common ratio? Well, 1 multiplied by what will give me negative 3? Well, 1 multiplied by negative 3 will give me negative 3. So 1 times negative 3 is negative 3. negative 3 times negative 3 is 9, which is not 5. So the common difference does not work here as well. So what are we going to do? Well, let's just remember our formula for a minute. An is the first term plus n minus 1d. And we don't know what d is. We don't even know if this is an AP or a GP. Those negatives there are really giving me some problems, right? So here what? Let's ignore the negatives for now. Let's just go 1, 3, 5, 7. So without those negatives there, it's quite easy to see that I could add 2. I could add 2. I could add 2. I could add 2. And so we would have a common difference of 2. And so let me try to work out what is this, the series for this. The sequence for this then. Yeah. So the sequence here, an, will be the first term 1 plus n minus 1d, which is 2. So you multiply that out. An is 1 plus 2n minus 2. And of course, 1 minus 2, an is 2n minus 1. That's quite interesting. So I know that 2n minus 1 will give me this normal odd number sequence here, 2n minus 1, right? So now, let's compare it with this sequence here. Each one of these things, if it wasn't, we're just ignoring the negative, each one of these things is supposed to be 2n minus 1. So this is 2n minus 1. This here is 2n minus 1. This here is 2n minus 1. In this case, n is 1, n is 2, n is 3, and n is 4. Now, if we ignore the negative signs now, we're just ignoring the negative signs here, we'll see that it'll work. When n is 1, 2 ones are 2 minus 1 is 1. When n is 2, 2 twos are 4 minus 1 is 3. You know, without the negatives, they will work. But with the negatives, I am seeing here now that this one, when n is 2, this answer will end up being a negative. And then this one, when n is 4, that number will, so even n numbers will give us negatives. That is quite interesting, right? So what if we multiplied this by negative 1? Yeah, and we multiplied this by negative 1, right? How could we multiply this by negative 1 without I mean, obviously we need to multiply everything by negative 1, right? So let's just pull these two down here. These are the negative guys here now. And we'll try to multiply this by negative 1. We'll try to multiply this by negative 1. But how could we do that? If we multiply this one by negative 1, the answer will end up being negative, right? So what's going on here? Well, maybe we could use n to help us. So if I put negative 1n to the power of n, well, that is negative 1 squared, which is positive 1. So that removes the negative. But what if I put negative 1 to the power of n plus 1? Well, that's 2 plus 1, which is 3. That'll be negative 1 to the power of 3, which is negative 1. So n plus 1 keeps it negative. Yeah. If I put negative 1 to the n plus 1 over here, I'll see n is 1 over here. So 1 plus 1 means I'll have negative 1 squared, which is 1. So over here, this will remain positive. Let's look at this one now. Negative 1 to the n plus 1, which will be negative 1 to the 4 plus 1, which is 5, which will give me negative 1. Odd numbers will remain negative, and even numbers of n will give me positive. Yeah? Well, not particularly even numbers of n, but n plus 1. When n plus 1 is even, I'll get a positive answer. When n plus 1 is odd, I'll get a negative answer. So this is quite interesting here, that in order to facilitate those negatives, I had to add this negative 1. So therefore, an could be seen as negative 1 to the power of n plus 1 multiplied by 2n minus 1. Very interesting one indeed. And of course, you know, I must give you one that is challenging at least. So I hope you definitely understood how we got that. And so obviously, to put it in terms of summation, it would be, now remember, this last term here is 99. So if the last term is 99, I wonder what n is going to be. And it should be a similar situation for the 99. It should be a similar situation with the first one. Because as you can see, the first one was even numbers. And so even numbers, to get to 100, we ended up getting 50. So the odd numbers, maybe the 50th number will end up being negative 99. So let's try n is 50 to see if we'll get negative 99 here. It's supposed to be negative 99. So A50 will be negative 1 to the power of 51 times 2 to the 50, 2 times 50 minus 1. And let's see what this works out to be. This will be, well, of course, this is a negative number. This is 100 minus 1, which is 99. And so we will get negative 99. So yes, 99 is the 50th number. So therefore, I could come and say that the summation from n is 1 to 50 of negative 1 to the n plus 1 into 2n minus 1. So this one was definitely a challenge here. So with number 2, we have to find the summation from r is equal to 1 to 3 of AR for part A when AR is 2R minus 1. So that means that for part A, I want the summation from r is 1 to 3 of 2r minus 1. And that is going to be when r is 1 plus when r is 2 plus when r is 3. 2 minus 1 is 1, plus 2 2s are 4, minus 1 is 3, 2 3s are 6, minus 1 is 5. So the answer here is 9. And then we have to find for this ugly looking guy here, which is the summation from r is 1 to 3 of negative 1 to the r plus 1 into a quarter r, or we could say r on 4. So we had to find, first of all, when r is 1. So when r is 1, that'll be squared times, and we could call this r on 4, so it'll be times 1 on 4, plus negative 1 when r is 2. 2 plus 1 is 3, and then we'll have here 2 on 4 plus -1 when r is 3. 3 plus 1 is 4. And then we'll have 3 over 4. And this should give us a quarter over here plus, this is negative. Well, first of all, this will make it a negative. So this will be minus 2 over 4. And this will make it a plus 3 over 4. I'll keep everything over 4. So 2, 3, and 1 is 4. 4 minus 2 is 2 over 4, which is a half. Now let's talk about part 3 here, or number 3, part A. We have to find the summation from I is equal to 4 to 9. Yes, from I is 4 to 9 of 3ai, where ai is 2i plus 5. And that's a subscript I, but that's 2 multiplied by I, right? So therefore, I could remember that I could take this and put it on the outside. So that'll be 3. The summation from I is 4 to 9. 3 times of a subscript I, which will be 3 times the summation of I is 4 to 9 of 2i plus 5. And so we could find the summation and multiply by 3 after, right? So let's find this summation here now. This summation will be from I is 4 to 9, so that is 2 times 4 plus 5, plus 2 times 5 plus 5, plus 2 times 6 plus 5, plus 2 times 7 plus 5, plus 2 times 8 plus 5, plus 2 times 9 plus 5. 4 2s are 8, and 8 plus 5 gives me 13 for the first one. Plus 5 2s are 10, and 5 is 15. Plus 6 2s are 12. 12 plus 5 is 17. Plus 7 2s are 14. 14 plus 5 is 19. Plus 8 2s are 16. Plus 5 is 21. Plus 9 2s are 18. Plus 5 is 23, I believe. Give us 108. Oh, we ain't done yet. We still didn't multiply by 3. So now the final answer, therefore, 3 times, I should rewrite it as the summation of I is equal to 4 to 9 of 3ai. It'll be 3 times 108, which is 324. We have a similar question here for part B, that we have the summation from I is 7 to 9, this time of -4a to the I, which is -4, the summation of I is 7 to 9 of a to the I. A to the I there is 5 minus 3i. So let's find the summation part first, right? So therefore, that implies that we will have 5 minus 3 times 7 plus 5 minus 3 times 8 plus 5 minus 3 times 9. And that'll give us 7 3s are 21. So 5 minus 21 is -16. Plus 8 times 3 is 24. So 5 minus 24 will give us negative 19. And of course, 9 times 3 is 27, so 5 minus 27 will give us negative 22. So minus 16 minus 19 minus 22 will give us minus 57 in all. And of course, we have to multiply that by negative 4. So therefore, the summation of I is equal to 7 to 9 of negative 4ai is going to be negative 57 times negative 4, which is 228. We have part C here now, where we have the summation from I is 2 to 4 of A plus B, two sequences here, and we know this rule that is equal to the summation from I is 2 to 4 of A plus the summation of I is 2 to 4 of B. So we could do the summation of A over here. Remember, that'll be the summation from I is 2 to 4 of A is 3i plus 4. And then I'll have plus the summation from I is 2 to 4 of B is 2i minus 3. So we'll work out this one over here. This one is 3 times 2 plus 4 plus 3 times 3 plus 4 plus 3 times 4 plus 4. Yeah, and so this will give us 3 2s are 6 and 4 is 10 plus 3 3s are 9 plus 4 is 13. 4 3s are 12. 12 plus 4 is 16. So 16 plus 13 plus 10 gives us 39 on this side. And of course, I'll be adding it to this one here. This one will turn out to be 2 into I minus 3 plus 2 into I is 3 minus 3 plus 2 into I is 4 minus 3. So this will be 2 2s are 4 minus 3 is 1 plus 2 3s are 6 minus 3 is 3 plus 4 2s are 8 minus 3 is 5, which is 9. So now on this side I'll have 39 plus 9, which is 48 total. Now I have part D. The summation of I is equal to 4 to 6 of AI minus 9. And we know about this already. We know that this will be the summation of I is equal to 4 to 6 of AI minus N, which is 6 times 9. This is the summation from I is equal to 4 to 6 of, in this case, we have 8i plus 1. So that will give us 8 times 4, because I is from 4 to 6, so it's 4 plus 1 plus 8 times 5 plus 1 plus 8 times 6 plus 1. So 4 8s are 32 and 1 is 33. 5 8s are 40 and 1 is 41. 6 8s are 48 and 1 is 49. 123. So therefore we'll have 123 minus 6. 6 9s are 54. So 123 minus 54 gives us 69. All right, so moving on, we have these AP arithmetic progression questions here. We already did the first one in class. So let's start with number 2. And number 2 here, we have to find the sum of the first 100 odd numbers. Now the odd numbers are starting from 1, 3, 5, 7, dot, dot, dot. And we have to find the sum of the first 100 odd numbers. So in this case, A is 1, and the common difference, well, if you add 2 to each of them, you'll get the sequence, so the series, sorry, and so the common difference is 2. And so what we have to do is we find the sum of the first 100 odd numbers. So the sum of an arithmetic progression, if we could remind ourselves, is n over 2 into 2a plus n minus 1d. So the sum is n over 2 into 2a plus n minus 1d. So this will be the summation of the first 100 terms, which is n 100 over 2 into 2 times a. Remember, a is 1, right? Plus n minus 1, which is 99, times d, which is 2. This makes more sense. 99 times 2 is 198 plus 2 is 200 times 50 gives us 10,000. So 10,000 is the sum of the first 100 odd numbers, right? So this is the first 100 odd numbers and the sum of the first 100 odd numbers. Now we have the second 100 odd numbers, and they want us to find the sum of the second 100 odd numbers. The thing is that this formula, when you find S100, you are finding from 1 to 100. So this formula gives you the sum of the whole thing. So to find the sum of just the second half or the second 100, we will need to find the sum of the first 200. So we need to find the S of 200 and then minus that first 100. So the S of 200 is going to be 200 over 2 into 2 times A plus 199 times 2. So that is 398 plus 2 is 400 times 100 is 40,000. So we have 40,000 here for the summation of the first 200. So therefore, the sum of the second 100 terms will be the sum of the first 200 minus the sum of the first 100, which will be 40,000 minus 30,000, which gives us, no, not minus 30, minus 10,000. The answer is 30,000. Now we see in here that for our AP, the third term is 5. So that means that A3 is 5. The 13th term is 10, and this is number 3 we're talking about here. So A13 is 10. And of course, we have to find the common difference, the first term and the sum of the first 30 terms. Well, we know that for our AP, we're talking about a sum of A to the n, not the sum, but the nth term of our AP is A plus n minus 1d. So, in this case, we know what A3 is, and that is A plus, and n is 3, so 3 minus 1 is 2d, and that is 5. Let's call this equation 1. And A13 implies we have a plus, this is 13 is n this time, so it'll be 12d, that is n minus 1, right? And that is 10. So now we have equation 1 and equation 2, and I will minus equation 1 minus, actually I'll do it the other way around. I'll do equation 2 minus equation 1. Equation 2 minus equation 1, the a's are gone. I'll have 12 minus 2 is 10d, and I'll have 10 minus 5 is 5. Therefore, d is 5 over 10, which is a half. So now that we have d is equal to a half, we sub in, let's go with equation 1. I have a plus 2d is equal to 5. Of course, I'll get a plus 1 is equal to 5, so a will be equal to 4. And of course, the sum of the first 30 terms, which will be S30. And that is n over 2 into 2a plus n minus 1d, which gives us 30 over 2 into 2 times a, which is 4, plus n minus 1 is 30 minus 1, which is 29, times d, which is a half. Interesting. And so this works out to be 29 divided by 2. Plus 4 2s are 8, multiply by 15, and I get 337 and a half. So for number 4 here, we need to find the sum of the first 50 multiples of 3. So with multiples of 3 now, what do we have? We have 3, 3 2s are 6, 3 3s are 9, 4 3s are 12, 5 3s are 15, dot, 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 right? The first term is 3, and the common difference, as you can see, if you add 3 going up the road, the common difference is also 3. And so we need to find the sum of the first 50 multiples of 3. So the sum 50 is equal to n over 2, which is 50 over 2. And I'll just write it over here. Sn is n over 2 into 2a plus n minus 1d. So we have n over 2 into 2 times a plus n minus 1 into d, 3825. Now we have to find the sum, hence find the sum of the second 50 terms. So of course the second 50 means we'll have to find the sum of the first 100 and then minus the sum of the first 50. So the sum of the first 100 will be 100 over 2 into 2a plus n minus 1 times d, and that will work out to be, to give us 15,150. Therefore, we have the sum of the second 50 terms will be the sum of the first 100 minus the sum of the first 50, which is 15,150 minus 3825, and that gives us 11,325. So next up, we are talking about the same kind of question, but for a GP this time. And the rest of the questions were done in class. Number 1 was done in class. We see in number 1 over here. When we did number 1 in class, Okay, so let's talk about number one here, and we have the same type of questions, but this time we're dealing with a geometric progression. So, and we have a little bit of a cheat sheet here that shows the nth term for our AP and a GP, as well as the sum for our AP and the two different sums for a GP given what R is. It does depend on R, yeah? So we have that to help us out there. So number one, for a GP, the fifth term is a half. So I'll put A5 is a half. The 10th term, A10, is negative 1 on 64. And so we have to find the common difference, the first term, and the sum. So the common difference here, well, of course, we have our, don't forget the an is ar to the n minus 1. So we have a5 being a times r to the n minus 1 is 4, and that is going to be a half. This is our equation 1. And then a10 is a times r to the 10 minus 1, which is 9, and this is going to be negative 1 over 64. That is our equation 2. And of course, what I'll do is I'll take equation 2 and divide it by equation 1. Why am I doing this? Because I want to get rid of the a's. And because that I have no addition and subtraction, those a's are glued together. So I can't just minus or add the equations. That wouldn't help me get rid of the a's. So I'll have to, and it'll help reduce the r's as well if I divide. So I divide an equation 2, which has the larger r value in terms of the that. So that'll be ar to the 9, which is larger than ar to the 4. So the division will be a little easier, but on this side, I will have the negative 1 over 64 being divided by 1 over 2. And in this case, we could see here that 4 of these will cancel with 4 of these, so I'll have 5 remaining, and of course the a's will cancel with the a's. So I will end up with, and look, I left this 1 all the way over here. Ooh. I will end up with r to the 5 being, and on this side now I have what? It'll be 1 over 64 times 2, and of course that will give me negative 1 over 32, and so I will throw the 5 across, so r will be the fifth root of negative 1 over 32. And of course I can have a negative in my root sign if the root itself is an odd number. If the root is an even number, you cannot have a negative in there. That would not exist. But if the root is odd, then you can have a negative. Yes, you can. So what this will end up giving me here is r is equal to negative 1 over the fifth root of 32, which is r is negative 1 over 2. So now I will sub into, let's go with equation 1, right? A times r, negative 1 over 2 to the power of 4 is equal to a half, right? I could do this, of course, this is an even power, so this will end up being negative. So 2 2s are 4 2s are 8 2s are 16 is equal to a half. I'll throw across that a is equal to a half times 16 on 1. So a is going to be 8. And now that I know that a is 8, so just recall that r is negative a half, and I'm supposed to put small r. And then a, we have 8, and recall that the s of n is a into 1 minus r to the n all over 1 minus r when r is less than 1. So what do I want? The sum of the first 20. So the sum of the first 20, S20, is going to be a, which is 8 into 1 minus r to the power of 20 all over. And do I have r? Yes, I do have r. R is what? R is negative a half minus a half, all to the power of 20, right? Into 1 minus r, which is negative a half. All right. So this is going to be, well, the denominator is going to be 1 plus a half. And on top, I'll have 8 into 1 minus this 1 over a half to the power of 20. That number is so small that it's almost 0. So because it's almost 0, it's not exactly 0, but I'm not going to work with that huge, very, very small number. It's so small, it'll have a lot of digits because it's so small. And a lot of decimal places, you know. The more decimal places you have, the smaller, right? So, yeah, I'll just approximate it at 0. So S of 20 is going to approximate to 8 divided by, because 8 times 1 is 8, and over here I'll have 3 on 2, which gives us 8 multiplied by 2 on 3, which gives us 16 on 3. Notice that because r is a fraction, it's between 1 and negative 1. So because r is a fraction, implies that this GP is converging, and therefore the sum to infinity converges towards 16 on 3. Now for a GP, the third term is 32, number 3. So A, the third term, is 32. And the seventh term is 8,192. We have to find the common difference. We have to find the first term. So again, an is equal to ar to the n minus 1. Therefore, a3 is going to be ar to the 3 minus 1 is 2, and that is 32. This is equation 1. And a7 implies ar to the 6, which is 8192, and this is equation 2. And of course, I'm going to take 2 and divide it by 1. So we'll have ar to the 6 divided by ar squared, and that is equal to 8192 divided by 32. Generally, we're trying to get the bigger numbers being divided by the smaller numbers. The a's will be gone. 2 of the r's will be gone. I'll have 4 r's left. So r to the 4th is equal to this 8192 divided by 32, giving me 256. And I have a feeling I know where this is going. R is going to be the 4th root of 256. R is going to be is 4. So now that we have R is 4, we could come and we could find A by subbing in equation 1. So equation 1 is A, R squared is 32. So A times 4 squared is 32. So A will be 4 squared is 16. So that's 32 divided by 16, which is 2, I believe. And so therefore we will have A to the n being 2, that is A times R to the n minus 1. And of course we have to find the sum of the first 10, so S of 10. And in this case, R is greater than 1. So I will use the A to the R to the n minus 1 into R to the n minus 1 all over R to the n minus 1. No, not R to the n minus 1, sorry. R minus 1. And so S sub 10 is going to be A, which is 2, into R, which is 4 to the power of 10 minus 1, all over R, which is 4 minus 1. So 4 to the power of 10 is a very big number, minus 1 is still a very big number, multiplied by 2 is an even bigger number, and we get 2,097,150, all divided by 3. So the sum of the first 10 terms is going to be 699,050. We are finding the sum of the convergent geometric series here. For each GP, we have to find the common ratio and the sum to infinity, and we are doing part B. We have 3 plus 3 on 2 plus 3 on 4, and it seems to me that the common ratio is a half, because 3 times a half is 3 on 2. 3 on 2 times a half is 3 on 4. So I will say the common ratio is a half, and the first term is 3. So the sum to infinity, and we'll notice here that R is indeed a fraction, which means that it will be a convergent series. So the sum to infinity is A, which is 3 over 1 minus R. Just recall, the sum to infinity is A over 1 minus R. So it'll be 3 over 1 minus a half, which is 3 over a half, which is 3 times 2, which is 6. For part C, we have 3 over 5 minus 2 over 5 plus 4 over 15 dot dot dot. Now this one's a little bit tricky. 3 over 5 multiplied by what will give me 2 over 5? Well, let's see. I have the 5 there. The 3 is gone totally, so I'll divide by 3. So the 3's will cancel, and then I'll have 1 multiplied by 2 to give me 2 over 5. So we have 2 over 3 here. If I multiply this by 2 over 3, of course it'll have to be minus 2 over 3 in order for me to get the negative. So if I multiply this by negative 2 over 3, well, 2 2's are 4, and 5 3's are 15, yes. So we have a common ratio of negative 2 on 3. And we have the first term being 3 on 5. And we could see here that yes, it is a fraction. So it is convergent. So the sum to infinity is a over 1 minus r, which will give me 3 over 5 divided by 1 minus, and r is negative 2 on 3. So this gives me 3 on 5 into 1 plus 2 on 3, which is 3 on 5 into 3 over 3 plus 2 over 3 is 5 over 3. Well, look at that. So that's 3 over 5 multiplied by 3 over 5, which is 9 over 25. So the sum to infinity is 9 over 25. And we have part D here, where we go with 10 plus 2 plus 2 over 5. And of course, it looks like this is a 1 over 5 situation. Right? So r will be 1 over 5, and a is indeed 10. And so the sum to infinity is a over 1 minus r. The sum to infinity is going to be 10 over 1 minus 1 over 5, which is 10 divided by 5 over 5 minus 1 over 5 is 4 over 5, which gives us 10 multiplied by 5 over 4. And of course, 2 2s are 4, 5 2s are 10, 5 5s are 25 over 2, which is about 12 and a half. So now we have the investment questions, and we have the first question here. And the first question tells us that a man bought a car for $120,000. So the initial investment for the car is $120,000. Each year, the car depreciates by 8%. So that means that after the first year, the price of the car is going to be P minus, because it's depreciating, so it's going to be minus 8% of P. And so we will now have P into 1 minus, and we wouldn't use 8 yet, we could use R over 100, right? Because we are looking for a formula in terms of R. So a R percent, right? After the second year, the car will depreciate again. It'll depreciate by minus an 8% from P1. So it'll be P1 now minus the 8% of P1, which ends up being P1 into 1 minus R over 100, and this is P2, right? So we could see here that P1 is P into 1 minus R over 100. P2 is P1, which is this, times this, which gives us P into 1 minus R over 100 squared. So we could clearly see that there is a relationship here between N and this N here, because this is the same term throughout. So because it's the same term throughout and the only thing that changing is the power, I could safely say that Pn now is P to the 1 minus R over 100 to the power of N. So now I could find how much after 10 years, which is the principal, 120,000, into 1 minus the 8% all to the power of 10. And of course, 8% is 0.08. 1 minus 0.08 gives me 0.92 to the power. So 0.92 to the power of 10 is 0.43 multiplied by 121.23 gives us about 52,126.61. And so this is how much the car is going to cost after 10 years. Now you notice here that for every year I get pretty much the same term. Yeah, so after the first year, it's this term in terms of P. We want to get it in terms of P because P is the initial investment. So we want to have our final formula in terms of P. So this is why with the second year, I substituted P1 to be in terms of P, and then I end up getting the same expression, but this 2 matches with this 2. So once we see that, we could go ahead and put N. Now, it will not always be like this. As we could see in the next couple of questions, it may be a bit trickier. So let's check out number 2. A woman makes an annual deposit of 25,000 into a bank account. So that means that the first deposit P is 25,000. Right? The money gains interest, an annual deposit, of course. The money gains interest at 3% annually. So we want to find out how much after the 10th year is it going to have. So the first P is 25,000. After the first year, it's going to be what? That principal plus the 3% of the principal, so it'll be this, plus the other P, the other 25,000 that she will input this year. So if we factor this out, we will get P into 1 plus R over 100 plus P, and this is P1. Now we know that R is 3%. So let's see if we could get P2 now. So P2 is going to pretty much be the same thing. It's going to be P1 plus the R percentage of P1 and then plus another P. So if we factor this now, right, it'll be P1 into 1 plus R over 100, and then we have another P. Of course, we want it in terms of P, so I will substitute P1 for this. So now I will have P into 1 plus R over 100 plus P, right? And all of this is P1 multiplying by this, 1 plus R over 100, and then we add in the other P. Now this other P is separate, so I could multiply this inside of here. This multiplied by this will give me P into 1 plus R over 100 squared. And then I'll have plus P into 1 plus R over 100. And then I have plus P. Now, this is P2 now. And P2, we have it in terms of P, but in this case, it's not the same as this. It's definitely different. It's not just a simple matter of the power changing. Yes, we see P2 has the power of 2 in it, but the other p-values, we do have other terms that were added. So let's try to find P3 this time. And P3 will be the same thing, P2 plus R percent of P2, and then we add in another P. And of course, P2 is all of this. So let's factor this out first. It'll be P2 into 1 plus R over 100 plus P. Now we could sub this for P2. So P2 is all of this, P into 1 plus R over 100 squared plus P into 1 plus R over 100 plus P, all, this is P2 here, and it's all going to be multiplied by 1 plus R over 100 plus P. Now, of course, this 1 plus R over 100 will multiply throughout. So I will now get P into 1 plus R over 100 cube plus P into 1 plus R over 100 squared plus P into 1 plus R over 100 plus P. And so what's happening in this case is, instead of getting the same thing like we saw in the other question, in this case we actually get in an arithmetic progression, a geometric progression of its own, right? So every single one is represented by a geometric progression. So we could see here that this geometric progression, it starts with P, and this will be after the first year, this will be after the second year, and I mean all of this, and then all of this will be after the third year, right? So if we take this as being the first term, we would have to multiply by 1 over R times 100 to get the second term, multiply that again to get the third term, multiply that again to get the fourth term. So now, in this case, we actually have this expression being a GP itself. And in this GP, we have R, which is the common ratio, being 1 plus R over 100, right? Where we have A being P. And so now we could say, well, you know what? Because what do we want to find? The sum after 10 years. So the sum after 10 years now, remember S sub n is A into, now R is obviously going to be greater than 1 because it's 1 plus whatever it is, and this is 3%. We know this is 3%, right? So let's work out R one time. We could actually work out, because remember the formula is 1 A into R to the n minus 1 all over R minus 1. So R is 3%, which is 1.03. And A is 25,000. So now we will have 25,000 into R, which is 1.03 to the power of n, which is S10 minus 1, all over 1.03 minus 1. So what do we have here now? 8597.9, and that's going to be divided by 0.03, because 1.03 minus 1. And so that final answer, 286,596.98. So this one was a little bit different because we did not end up getting the same expression where we could have just formulated our own formula. Now, this one, we actually got a GP itself. And so we had to use our GP formula. Right, so number 3. The PTA sets up a fund to pay an annual top student prize of $600. So they pay in it annually, right? 50,000 was placed in a fixed deposit which pays an interest per annum of 3%, and every year when the interest is paid, the prize money is withdrawn. How much is in the account after the 10th withdrawal? So we know that P is 50,000. We know that R is 3%. And we know that we'll call it A, that's the amount that is withdrawn, and that is 600. Yeah, then that's big A. So we could see here that P is 50,000. That's what we start the account with. P1, that is gonna be P, because we earn in 3%, so P plus 3%, and I wouldn't put the 3 just yet, I'll use R percent of P. And I can see that that is P into 1 plus R percent. And I mean 1 plus R percent, remember R is 3%, which is 0.03. So this will be P into 1 plus 0.3. Yeah, and I'll just put in the R there to make it a little bit simpler, right? P2 is if I was to take P1 and add, oh no, we forgot something, right? After the first year, we have to withdraw the amount A, so it'll be P into 1.03 minus A. After the second year now, we will have P1 plus the R percent of P1, and then I'm gonna minus another A, because every year I'm minusing A, right? So this will be P1 into 1 plus R over 100. Remember, 1 plus R over 100 is 1.03. And so P1 now is this. I could substitute this P into 1.03 minus A. That is P1. All multiplied by 1.03. And then I have this minus A on the outside. So that will give me P2. And this is P1. P2 is going to be 1.03 times this is P into 1.03 squared minus A into 1.03. And then I have this minus A. So we see in another situation here where whenever we add in or subtract in a number, it forms a GP of its own, right? And if we look after the third year, for example, we will see that it'll be P2 plus the R percentage of P2 minus another A. So that'll be P2 into 1 plus R over 100 minus A. Remember, 1 plus R over 100 is 1.03 minus A. Now let's substitute P2 in here. So P2 is P into 1.03 squared minus A into 1.03 minus A, and that is P2, all multiplying by 1.03, and then we have minus A. So now we get P3 to be P into 1.03 cube minus A into 1.03 squared minus A into 1.03 minus A. And we could definitely see a pattern starting to form here. So obviously, with P to the N, right, P to the N is going to be this, which is the initial principal into 1.03 to the power of N, because we can see this 3 and this 3, this 2 and this 2. So we know that's going to be to the power of N. Then we're going to have minus, and we have all of this business here. Let's factor out the A. And if we factor out the A, we're going to get inside the brackets 1.03 squared minus 1.03 minus 1. Actually, not minus, because we're pulling out minus A. So all of this is going to be plus on the inside here. We see in here that this forms a GP of its own, where A is 1 and R is 1.03. So now we could find the summation of inside of here. And the summation of inside of here. And of course, the summation to the N, S to the N, is A into R to the N minus 1 all over R minus 1. And because A is 1, then inside of here we will have R to the N, and that's 1.03 R to the N minus 1 all over R minus 1. Yeah. And so that means that inside of this brackets, we gonna have minus A into 1.03 to the N minus 1 all over 0.03. We could bring the 0.03 on the outside to give us negative A over 0.03 multiplied by 1.03 N minus 1. And so now we have P to the N being this minus A on 0.03 into R 1.03 to the N minus 1. And so now we could find P10, which is P 50,000 times 1.03 to the 10 minus A, which is 600 over 0.03 into 1.03 to the 10 as well minus 1. So P10 is going to give us 1.03 to the power of 10 times 50, 123, and that is 67,195.882, we'll call it. And we end up get about 6873.33. And so our final answer is going to be $60,317.49. So these here you definitely have to be careful with. If it is you're not just ending up with a simple repetition and it always have a plus and a plus or a minus for every year, we end up getting like a GP inside of a GP, so it ends up being a little more complicated. The other questions though should be a little simpler to deal with, so let's check them out. Robert places $48 in his piggy bank. So $48 is the first term. At the beginning of the second and third month, he places 63 and 78. So 63 and 78. Now this is a piggy bank, so it'll have no interest go in here. We don't see no rate percent, right? If his saving continues in this manner, how much would he save at the end of the 51st month? Well, let's see if we could find a common difference here. 63 minus 48 is 15, and 63 plus 15 is indeed 78. So we do have a common difference of 15, with the first term being 48, and this time we have a simple AP, and the summation of an AP is n over 2 into 2a plus n minus 1d. And so what we want to find after 51 months, the S sub 51 is n, which is 51 over 2 into 2 times a, which is 48, plus n, which is n minus 1 is 50, times d, which is 15. And the final answer gives us around 21,573. And number 5, we have another depreciation. So Ramona bought a boat for $225,000. That is P. And once you're dealing with a percentage, you know it's GP. Each year the boat depreciates by 10%. So after the first year, it's gonna be P minus R over 100 times P, which is P into 1 minus R over 100. After the second year, it's gonna be P1 minus R over 100 of P1. And of course, P1, I could factor out the P1 there to give me 1 minus R over 100. And of course, P1 is really P into 1 minus R over 100 times 1 minus R over 100. So now we have P into 1 minus R over 100 all squared. And so I could see this is an easier situation where, you know, P1 is to the power of 1, P2 is to the power of 2, but it's the same exact expression. It don't have no anything added or minus or anything. So I could safely say Pn is going to be P into 1 minus R over 100 to the power of n. Now I could plug in P of 15. And that is going to be 225,000. That is P into 1 minus 10 over 100, all to the power of 15. So this works out to be, gives us $46,325.50. And this is the price of the boat after 15 years.